Okay, here's an applet to show you correlation and regression. So I'm going to add some data points. Okay, just give me a few minutes to add some points up here. Okay, and you can see that I'm making them kind of in a pattern, a downward pattern. So we know that R should be negative. So our correlation coefficient, okay, right now is negative 0.936. Notice as I add points in, it changes it. Okay, so I'm going to put about 20 points in there. Okay, so there's 20 points. So we have that scatter plot. And if I click on Show Residuals, okay, what that's going to do, it's going to draw the least squares regression line and then show the residuals. Remember that all the residual is the difference between the observed value and the expected value. So it's the distance between the point on the line and the point of the observed values. And remember, what a least squares regression line wants to do is minimize the sum of the squares of those residuals. So the residuals for any point below the line is going to be a negative number, and any point above the line is going to have a positive residual. Okay, you want to minimize the sum of the squares, and that's where that regression line comes from. Okay, now let's see what happens. Here we have a very strong negative correlation. So the Pearson's correlation coefficient, or the R value, would be right around negative 0.96, which indicates a very strong negative linear correlation. Okay, if I draw that line in there, so show the least squares regression line. If I add another point, notice what happens to that line. It moved. Now, what I can do is that last point I added, I can click and drag it. And notice, as I drag it upward, oops, sorry. My computer's being touchy. Here, I actually add another point there on accident. Just 1 second. Let me put this one back toward where the data is trending. And then I'll take this one here. Okay, so as I drag that line closer to the data points, notice the correlation coefficient up here is getting closer to -1, which means it's getting a stronger correlation. And as I drag it away from the data points, notice it's becoming a lot smaller. Okay, or closer to 0, I should say, or less negative. So you can see that if you have an outlier in a set of data, like this point that I'm dragging, like when it's way up here, it's most likely an outlier. That has a very large effect on the correlation coefficient and how correlated the data is going to be. Okay, now, even if I put it way out here to the right, but it's down further, notice that that's fairly close to the line. So that has a pretty strong negative correlation still. But if I move it over to the left-hand side here, okay, notice that changes the line again. Okay, if you show the mean X and Y lines, that's just going to show the average X and the average Y, kind of as like a bullseye. So the average, so X bar comma Y bar, that point would be right here where they intersect. And I'll take that point again, I'll drag it around so you can see what happens. If I drag the point up, the horizontal line should get higher. Okay, so see how that gets higher? Oops, sorry about that. And then if I drag it down, the average Y, the horizontal line gets lower. If I move to the left, that vertical line moves to the left. And if I move to the right, moves it to the right. But what you might notice is that least squares regression line, hey, this blue line here, always goes through that point, X bar comma Y bar. And if I click on Show Residuals again, notice that, again, if I move this far away, the residual on that point becomes huge, and it also affects the residuals on all the other points, because that line is trying to minimize the distance between all the points, and this point here, this outlier, is really affecting where the line is. Okay, so that's just a quick example of showing you how an outlier can affect the line of best fit and how the residuals change.